first from the Aristotle said if there is a no constant motion, the force is secured. After that, Aristotle said, Galileo said, if there is a no force needed to maintain that motion. After Newton came and said, what is that? What he said? There is a change in momentum, the force is secured. There is a change in momentum, then there is a force is secured. Okay, so if we directly proportional to rate of change of his momentum. Okay, and so Newton gave the three laws. The first law is called inertia. Okay, what is that? If the until the external forces act, okay, the constant velocity will not be in the constant motion or in the state of rest. Okay, until the external force is acting on that object. The second law said the force is directly proportional to rate of change of its momentum. And third law said there are the equal and opposite forces which is acting on the object, which is acting on the object, that is called pair of actions. Okay, so now next one thing, what is the friction? Friction is nothing but there are three types of friction: static friction, kinetic friction, and rolling friction. So okay, rolling friction is much more smaller than that kinetic and static friction. Okay, so impulse. So where maybe the impulse, what is the impulse? The great force cannot be calculated at the short interval of time, but impulse can be calculated. Impulse can be calculated. Lambis, what he said, the force of each in the concurrent forces will acting on the object, then it's directly proportional to the sine of angle between the other two forces. Okay, so after we learn the static frictions and then what are the methods to reduce the frictions, kinetic frictions method to the ball bearings, and then what we are using oil. Okay, lubricant oil, everything is using. Okay, what is meant by friction? It's the interaction between the friction. Origin of the friction is nothing but interaction between the electromagnetic atoms. Okay, interaction between the electromagnetic atoms of the two surfaces. Electromagnetic atoms of the two surfaces. And then what is meant by centripetal forces? Centripetal forces is nothing but which is act towards the center. Which is act towards the center. What is the centrifugal forces? Centrifugal forces is nothing but which is act away from the center or opposite to the center, centripetal force. Okay, so centripetal and centrifugal forces, what are the difference? Okay, listen this one. Centrifugal forces always existed in non-inertial frames. Non-inertial frame, that is called only in the rotating frame. But centrifugal force which is happened in the both inertial and non-inertial frame. Okay, listen. Now there are energy and power. What? Energy and power. So we tell me what is that work? You may do a lot of work, right? Watching TV, scoring the scrolling the news feeding, the mobile. These are the work you are maybe thinking about that you have done something. Okay, but actually, what is that work? This is regarding with that related with that mechanical work. Okay, so the work is nothing but when the force is applied on the object, that object is displaced. An object is displaced. Then when the object is moved from here to here, the object moved from here to here, then there is some work is done by that force. There is some work is done by that force. Then it is called work done. Okay, so what is the work done? Work done is nothing but when an applied force is displaced in that object. When the applied force is displaced by that object. Okay, that force done some work in that object or on that object. Okay, that force done some work moving the object from here to here, displacing the object from here to here. It did some work on that object. Okay, so work done is actually the scalar product. Work done is actually scalar product. Okay, so if you want to do that work, you must need some energy, right? So that energy is nothing but capacity to do the work. Capacity to do the work. So the ability of the work, maybe you may tell like that. Okay, the energy is nothing but the ability to do the work. So without energy, we cannot do any work. Without energy, we cannot do any work. So work and energy are same. Work and energy are same. Okay, and also they have the same dimension. Okay, work done. Work done is nothing but the force displacing that the force and displacement are in the dot product or scalar product. So work done will be equal to F dr cos theta. F dr cos theta. What is the SI unit of this work done? Work done for the SI unit is nothing but for force Newton, for the displacement meter. Newton meter. meter, or you may write in the form of joule. Because energy caloric meter is formed by the joule, so we may see that one joule into 100 joules. Okay. Now, work done. What is the dimensional formula for this work done? What is the dimensional formula for this work done? So, work done, dimensional formula for this work done will be equal to force. So, mass into acceleration into displacement, length, right? So, this will be length. So, mass, for mass m, for acceleration L, t power minus 2, for length L. Okay, so everything should be in the capital X. So, what will happen? The dimensional formula for the work done, m L square t power minus 2. Same as for energy also, they have the same dimensional formula. Energy also, they have the same dimensional formula. Okay, m L square t power minus 2 is the dimensional formula for the work done. Now listen, what is happening if the work, when the work will be, our work done will be 0? When there is no force, if the force is 0, the first case, the force is 0, what will happen? F here cos theta. So F will be equal to 0. Then work done also will be equal to 0. Because I am not giving any force on the object. Okay. The object never gain any force from the external. Then what will happen? Then there is no work done. Right? Because whenever there is a work done, the force must be needed. So there is no force, then there is no work will be done. There is no work will be done by that object. So the force is 0, then work done will be equal to 0. The second case, suppose displacement equal to 0. I am giving the force, but there is no displacement by that object. Then what will happen? Again, the work done will be equal to 0. For example, I am giving the more force on this board. Okay, what will happen? The board or the wall will never move from here to there, right? Even though I am giving the more amount of force, much more forces on the wall, what will happen? That wall never moved by inch, right? So the force or the work done will be equal to 0. When there is no displacement, then the work done will be equal to 0. Okay, even more you are giving the much more amount of forces, nothing will happen to that wall because you are giving the wrong side, right? So next one thing, remember that one. What will happen to the force? If I am giving the force, but displacement is not happening, but what happened to my force? I am giving the more amount. That energy will be converted into vibrational energy, or it may be converted into heat energy. Okay, whenever you are pushing that one, you may feel the warm feel, right? You may feel that warm. So that means there is maybe work done will be 0, that energy will be converted. So the third one. If I am giving the perpendicular force, when the theta equal to 90 degrees, what will happen? For example, the force will be acting in this direction. I am lifting the object in this direction and I am moving in this direction. The theta will be equal to 90 degrees. What will happen? Then the gravitational force, which is will nullified by that force, so that net force will be equal to 0. So there is no work done will be done. Okay, there is no work done. When it moves in the horizontal direction, the gravitational force does not work on that object. When it moves in the horizontal direction, gravitational forces will not work on the object, so it can easy to move that object. Okay, so this one. What happened if that negative force is applied or negative work done? It's nothing but whenever the football player kicks the ball, okay, whenever they kicks the ball, what happens? When the goalkeeper blocks the ball, then there will be a negative work done because the force is not work done is nothing but force into displacement. When you are blocking that one, you are giving that force, which is that much lesser than that force in the negative direction. The negative direction or towards that the origin of the force. Then it is called negative work done. It is called negative work done. Okay. So there are many examples are given in your book. Look at the page number 169 and the 4.1. 169 and the 4.1. The box is pulled with the force 25 Newton. Okay, they given 25 Newton and is displaced by the 15 meter. Displacement by the 15 meter. The angle between the force and the displacement by 30 degree. So what is the work done by that object? So force they are given. What is the force they are given? 15, right? 25 Newton. The displacement will be equal to 15 meter. The theta theta will be equal to 30 degree. So what will happen? Cos theta will be equal to root 3 by 2. Okay. So work done will be equal to 25 into 15 into 30 degree. So what will happen? Cos 30 is nothing but cos 30 degree is nothing but root 3 by 2. So 25 into 15 into root 3 by 2. 7.5 make it 12.5 into 15 is nothing but 324 into 1.34. So 324.6 joules. Okay, this much of joules will be done. Work will be done by sources. Okay, will be done by the object and on that object. Okay, work done by the constant force. If the force is constant, but displacement is a little bit different, what will happen? I am giving the same constant force on this object, but this object will be displacement from the force here. After that, sometimes it will displace here, but there is a constant force. There is a constant force. Then there is a constant force. The total amount of a small amount of work done will be equal to FDR cos theta. FDR cos theta. Here the force is constant. Here the force is constant. So displacement only is happening. So F cos theta will be given in the same direction. Displacement only will be vary. Displacement only will vary. Okay. So the total work done will be equal to integration of initial displacement to the final displacement. F cos theta into dr. So F cos theta is a constant. So take it outside. So work done, total work done will be equal to F cos theta Rf minus Ri. Rf minus Ri. That means the final displacement minus initial displacement. Final displacement by initial displacement. Okay. Now suppose work done by the variable force. Work done by the variable force. What will happen? Work done by the variable force, that it's nothing but same thing. F cos theta, then F cos theta will be equal to R minus Ra. Work done by the variable force, then F cos theta dr will be equal to work done by the variable force. Now the second one thing, that is what we have for the work done. The next one, the energy. What is meant by energy? What is meant by energy? The capacity to do the work. Energy is nothing but capacity to do the work. So also the same as the dimension formula, it has a dimension formula m power square t power minus 2, as same as work. And also this energy is capacity to do the work, or it is the ability to do the work. Okay. So there are the two types of energies. The first one we call potential energy, and second one we call kinetic energy. Okay. So the first one, potential energy or kinetic energy. What is meant by potential energy? The potential energy is nothing but what? The potential energy is nothing but the object possesses the energy in the virtual state of rest. Okay, virtual state of rest. When there is an object in the rest, is possess the energy is called potential energy. When the object is moving, or when the object is moving, they possessing the energy, then it is called kinetic energy. The energy possessed by the body due to its motion, it's called kinetic energy. Due to the virtual state is called potential energy. It's called potential energy. Okay. But when you are comparing the isolated system, the total energy of the system will be constant or remains constant. Total energy of the system will be remains constant. Okay. So there is a total energy of the system is nothing but potential energy plus kinetic energy. Potential energy plus kinetic energy. Okay. Now the SI unit of energy is also Newton meter. SI unit of the energy also Newton meter or joule. What is mean by kinetic energy? The kinetic energy is nothing but the energy possessed by the object by virtue of its motion. Virtue of its motion. Okay. The body and the motion ability to do the work. Ability to do the work. Now, if there is no energy acting, then there is no work done will be done. There is no work done will be done. So, okay, tell me, what is that work and kinetic energy theorem? What is the relation between work and kinetic energy? Now, what is the work? Work is nothing but force into displacement. Force into displacement. Force into displacement. We know that one formula. F equal to ma. F equal to ma. The Newton's second law of motion. We know that F equal to ma. Now listen. We know this formula also from equations of motion. U square equal to 2 U square plus V square equal to U square plus 2V areas. Right? From here, what is A? A equal to V square minus U square by 2S. Substituting this here, it will become M A dot S. The total work done will be equal to A dot S, right? From this one. Now, the total work done will be equal to for M, for A, V square minus U square by 2S into S. SS will be cancelled. Then I can write MV squared by 2 minus MU squared by 2. Now, this is the final velocity and this one we call initial velocity, right? So, final kinetic energy minus initial kinetic energy. Okay, so I can write this final kinetic energy 1 by 2 mv squared, right? Minus 1 by 2 mu squared. So, final kinetic energy minus initial kinetic energy. So, the work done is nothing but rate of change of kinetic energy. Work done is nothing but rate of change of kinetic energy. So look at the picture. So kinetic energy is nothing but rate of change of nothing but half mv square minus half mu square. Kinetic energy of the body is always positive. Kinetic energy of the body is always positive. Final as initials. Okay. Now that's the expression. It implies that the work done by the force for the body changes the kinetic energy of the body, then the work kinetic energy called. This is called work kinetic energy theorem. Work done by the force on the body changes the kinetic energy of the body. Work done by the force. Okay, work done by the force changes the kinetic energy of the body. Then it is called relation between the work kinetic energy theorem. So, okay, what are the factors we know from this following? If the work done by the force on the body positive, then the kinetic energy is increases. Okay, work done will be positive, then kinetic energy will be increases. Suppose the work done will be on the body's negative, kinetic energy will be decreases. Suppose there is a negative kinetic energy, then negative work done, then kinetic energy will be equal to decreases. If there is no work done by the force on the body, then there is no change in the kinetic energy. Then there is no change in kind of work done, then there is no change in kinetic energy, which means that the object or body has moved at a constant speed, otherwise the mass remains constant. Relation between, what is the relation between the momentum and the kinetic energy? What is the relation between the momentum and the kinetic energy? Now listen. We know that kinetic energy, what is the kinetic energy? Kinetic energy equal to half mv squared, half mv squared. Now listen. We can write this one 1 by 2 m v dot d. Okay, v square can be write v dot d, right? V into v. Now on both sides, numerator and denominator, multiply with the m. So 1 by 2 m 1 by 2 m mv square and mv dot mv. Or you can write 1 by 2 so it's nothing but m square v square by 2m, right? So we can write m square v square is nothing but linear momentum, right? So p square by 2m because t equal to mv, then p square is equal to m square v square. Okay, so kinetic energy. So kinetic energy will be equal to p square by 2m, then p square equal to 2m kinetic energy. P will be equal to root of 2m kinetic energy. So this is very important. What is the relation between kinetic energy and momentum? Kinetic energy and momentum. Kinetic energy will be equal to p squared by 2m. Kinetic energy will be equal to p squared by 2m. From this formula we can find what is the kinetic energy of the object, what is the mass of the second object, what is the momentum of that object. Okay, so this is very important. Kinetic energy will be equal to p squared by 2m. For example, 4.7. Two objects of masses 2 kg and 4 kg. Two objects of the masses. There is a two object which is moving in the masses 2 kg m1. m2 will be equal to 4 kg. Okay. Moving with the same momentum. same momentum. P will be equal to 20 kg meter per second. 20 kg meter per second. Will they have the same kinetic energy? Will they have same kinetic energy or will they have the same speed? Now listen. First one we have to find what is the kinetic energy of one. First mass. Okay. So kinetic energy will be equal to 1 by 2 m1 p squared. P squared by 2 m1 will be equal to p square. What is the square? 20 square. 20 into 20 divided by 2 into 2. What is that? 400 divided by 4. This will be equal to 100 joules. First one. Kinetic energy of the second one. P squared by 2m. 2. 400. Say 20 into 20 divided by 8. Right. So 8 was 50. So 50 joules. So what happened? The first mass having the larger, because the mass will be reduced, no? So inversely proportional to the mass. So note that the kinetic energy of the first one is not equal to second one. Even though both having the same momentum, even though they have both having the same momentum, mass of the object is inversely proportional. So whenever the mass increases, kinetic energy will be decreases automatically. So here the less mass we have the 100 joules. Here we have the great mass. So when compare with this one, 50 joules we are getting. So kinetic energy of the first one will not equal to the second one. Now, kinetic energy of the heavier object is lesser kinetic energy and the smaller mass. It's because kinetic energy is inversely proportional to the mass. Inversely proportional to the mass. Okay. So, as the momentum, will have the same speed. Momentum P equal to mp. Mass into velocity. Both are the different masses. So they never have the same momentum. They have the same speed? No. They have the different velocity. That means different momentum. Okay, so what is meant by the potential energy? What is meant by the potential energy? The potential energy of the body associated with the state of rest. Okay, the energy possessed by the object or energy possessed by the body in the state of which of its rest or position. Potential energy of an object is the point defined as the amount of work done by the external forces moving the object at a constant velocity from the point initial location to the final location. Energy possessed by the body due to the gravitational forces give the gravitational potential energy. Suppose we are the height of the building. Here not with some stone. Here there is no forces acting. Gravitational forces is only acting. That gravitational forces is acting to bring the object from here to here. So the gravitational force is providing the gravitational potential energy to that object. Gravitational potential to that object. The energy due to the spring force and the singular forces give the rise to elastic potential energy. Okay. So the energy due to the electrostatic force on the charges rise to electrostatic potential energy. So these are the gravitational potential energy, surface of the earth. Okay. So we know that energy formula U equal to this symbol of energy, U equal to potential energy, U equal to FDR. So here there is changes in the object. Object is displaced from the one point to another point from 0 to h. Okay, FDR cos theta. So we know that the forces acting on the object will be equal to mg because mass is the gravitational force. So integration of 0 to from 0 to height of the object into dr. So upper limit minus lower limit. What will happen? This is nothing but mgh. So this much of potential energy will be stored when the object is dropped from the height of the building. Okay, so R will be equal to mgh. Note that potential energy stored in the object defined as a work done by the external force which is positive. Physically, it implies that the agency is applying the external force, transferring the energy to the object, which is then stored as potential energy. If the object is allowed to fall from the height, then the stored potential energy is converted into kinetic energy. Okay, and they are coming back to the one. But initially they have the potential energy here in the width of the building they have the kinetic energy as well as potential energy. At the bottom we convert again half mv square. After they convert into mgh, it is coming into rest. Okay, so this was the given. So how can zero acceleration? We will learn about the elastic potential energy on the later. Okay guys, love this for this week is enough. Next week onwards we will have the frequently we have the test. Okay, so be ready for that. From the first lesson, second lesson, third lesson will go. Okay, guys, Allah please take care.